Hello. Let's get the IUPAC nomenclature of this structure. We obey IUPAC rule in getting the IUPAC nomenclature. And the first rule is identification of longest carbon continuous chain. From this structure, the longest carbon continuous chain, followed by the functional group present to identify the functional group. And then we identify the substituent group if there is, or branch. Substituent group or branch. The first is longest carbon continuous chain. 1, 2, 3, 4. 4 carbon atoms, and so carbon as a 4, it is referred to as boots. It is referred to as boots. Then carbon to carbon, is it single bonds all through, or there is a double bond or a triple bond? From what we have here, it is carbon to carbon, single bonds all through, and that makes it to become an. Then we move to the functional group. Is there any functional group here? Yes, the OH functional group. OH functional group. And because it is located here, we now name this carbon to become carbon 1. We make this carbon to be carbon 1 because it is the carbon, the carbon that is located at the end where functional group is close to. And because of that, now we have 1, 2, 3, and 4 in a number of the carbon atoms. So at carbon 1, there is OH, and the OH functional group has the suffix of all. Has the suffix all. Therefore, it ends with all here. Now, this is the parent's name. This is the parent's name. The parent's name is butanol. But from what I said, we identify if there is any substituent group or branch. From here, carbon 1, is there any substituent group? By substituent group, we mean any of the halides, that is chlorine, bromine, iodine, or even it might be nitrogen, it can be sulfur, or the rest, or even oxygen if you like, that may be present, substituting or replacing hydrogen. Now, let's look at carbon 1. Is there any? No, except this functional group, which is of course a functional group, so it is not a substituent group, neither is it a branch. Carbon 2, there is hydrogen, and then there is no hydrogen here. It means that there has been replacement of hydrogen with chlorine. Therefore, this is a substituent group. And then we name it as chloro. But it is located at carbon what? Carbon 2. Therefore, it is 2-chloro. 2-chloro. Then carbon 3, there is hydrogen at the top, and the bottom has bromine. Therefore, bromine has replaced hydrogen. And because bromine has replaced hydrogen, it is now a substituent group. And because it is at carbon 3, we then say 3-bromo. 3-bromo. Carbon 4 has hydrogen, hydrogen, and hydrogen. Complete. Nothing has replaced hydrogen. It means that it is intact. Therefore, what we already have now is butanol, 2-chloro, and 3-bromo. These substituent names are to be written alphabetically. They are to be written alphabetically. So which one will come first? Bromo will come before chloro alphabetically. Therefore, in naming, these are the 3 names we have already derived according to IUPAC rule. So which one will come first? The first one is this substituent group, bromo, then the second one, chloro, then finally the parent's name, butanol. So the name of this structure now becomes 3-bromo. In between letter and number, it is hyphen. So 2-chloro, then butanol. Butanol. This is now the name of this structure, the IUPAC nomenclature of this structure. 3-bromo, 2-chloro, butanol. If you look at it, 3-bromo, 2-chloro, butanol. The OH group is located at carbon 1, so we can otherwise say butan 1 all. We can otherwise say butan 1 all. If you have not liked my page, please do well to like, do well to share, do well to follow, and also click the notification bell. Thank you. God bless you.